Welcome children. Today I am going to discuss few questions related to types of relations. In the previous class we learned what are reflexive relations, symmetric relations and transitive relations. Let us have a recap of the same now. A relation R is said to be reflexive if AA belongs to R for every A belongs to the given set capital A. Now if AB belongs to R implies BA belongs to R for every A comma B belongs to the given set capital A implies the relation is symmetric. Now if AB belongs to R, BC belongs to R implies AC belongs to R for every ABC belongs to the given set A as a transitive relation. Now if a relation is reflexive, symmetric and transitive, it is known as an equivalence relation. So here is a question. Show that the relation R in the set capital R of real numbers defined as R equal to set of an ordered pair A comma B such that A less than or is equal to B square is neither reflexive nor symmetric nor transitive. So here this is the relation. A should be less than or is equal to B square for the real numbers A and B. And we have to prove that that particular relation is not reflexive, not symmetric, not transitive. Children, here for proving a result which is wrong, it is enough to provide a counter example. So for proving the relation is not reflexive, I am taking A as half. So this implies 1 by 2 less than or is equal to 1 by 2 whole square is false. We cannot say that 1 by 2 is less than or is equal to 1 by 4. So it is false. That means AA does not belong to R for every A belongs to the set of real numbers. So we can conclude that R is not reflexive. Now for proving not symmetric, I am taking A is equal to 1 and B is equal to 2. So 1 less than or is equal to 2 square is true, but 2 less than or is equal to 1 square is false. So we can say that 1, 2 belongs to R, but 2, 1 does not belong to R. So we can conclude that R is not symmetric. Now for proving not transitive, I am taking the example like this. A is equal to 1, B equal to minus 1, C is equal to half. So here we can see that 1 is less than or is equal to minus 1 square is true. Minus 1 less than or is equal to 1 by 2 whole square is also true. But 1 less than or is equal to 1 by 2 whole square is false. So this means 1 comma minus 1 belongs to R. Minus comma 1 by 2 also belongs to R. But 1 comma 1 by 2 does not belong to R. So we can conclude that R is not transitive. So this particular relation we can see that it is not reflexive, not symmetric, not transitive. Now children, another question. I am taking the same set as the set of real numbers. And I am changing the relation like this. Let R is the set of all real numbers and the relation R is defined like this. R is equal to set of an ordered pair A comma B such that A less than or is equal to B. In this case, it is reflexive and transitive but not symmetric. Reflexive and transitive but not symmetric. So here for proving reflexive, we have to write the logical proof. Can we write A less than or is equal to A? This is true for every A belongs to capital R. So we can say that AA belongs to R for every A belongs to the set of real numbers. So R is reflexive. Now for proving R is transitive, let A less than or is equal to B, B less than or is equal to C. This implies definitely A less than or is equal to C. So we can say AB belongs to R, BC belongs to R implies AC belongs to R, and this is true for every ABC belongs to the set of real numbers. So we can conclude that R is transitive also. But for proving not symmetric, again for proving not symmetric, we have to take one example. We can take the example like this. A is equal to 1 and B is equal to 2. So 1 less than or equal to 2 is true, but 2 less than or is equal to 1 is false. So this means 1, 2 belongs to R, but 2, 1 does not belong to R. So R is not symmetric. So we can see that this particular relation is reflexive and transitive, but it is not symmetric. Children, in the next video I will explain one more question for proving equivalence relation. Okay.